Afternoon, guys. So we are going to look at turning points within differentiation. Hopefully we should be able to get differentiation sorted before the end of the week. But we just need to look at turning points, which you might see is where the gradient is 0. You should recognize some of these basic shapes. This is a positive coefficient parabola, which is like happy face. Some people remember it that way. You have a negative coefficient parabola, which is sad face. And then, I don't know if you remember or not when we were briefly sketching graphs, a cubic shape, you should remember, looks a little bit like that. And a negative power should look like this for a cubic graph. Okay, so the turning points, if you don't know, now you know, maybe you should learn. You might want to make notes about it, just a hint. You could pause, make notes. But anywho, with these turning points, it's essentially where the gradient is 0. You have 3 different types of turning points. You only need to worry about 2 of them. The third one is usually for A level. So you have a minimum, which is right there. You have a maximum. And here, even though this is not the actual maximum value, because the maximum value, it would just keep going on for infinity, this would be called a maximum point because it reaches at a maximum and then it goes back down. So that would be a maximum and this would be a minimum. Okay, and this is also a minimum right here and that is a maximum point right there. So this is the way I usually remember them, as long as, because I'm more of a picture person, as long as I can visualize what a graph should kind of look like, then you can kind of say, oh, okay, so there'll be 2 turning points, and if they ask me for the minimum, I'll go for the greater x value. There should be 2 turning points. If they ask me for the minimum, I'll go for the smaller x value. Okay, so if you are running through the examples, you will notice there is another technique that they use. So rather than visualizing this and finding a turning point and knowing what type of turning point it is, what they do is they say you find a turning point, then check the gradient just a little before and check the gradient a little after. And if the gradient goes from negative to positive, when you're increasing it, you will notice it's this. So that's a negative gradient and that's a positive gradient. Then you know it's a minimum point. And if the gradient goes from positive to negative, then that is a maximum point. If you do choose to go down this method, then this method requires a very small change. I wouldn't say if I knew that x equals 1, then I would test x equals 2 and x equals 0. You'd have to go for a very minute change. So if I knew the turning point was x equals 0, then I'd be checking at x equals 0.1 and I'd be checking at x equals negative 0.1. So it has to be quite small changes. Okay, sometimes it can get smaller than this, but they won't make it too complicated for IGCSE. That's more A level. Okay, but this is a method that people prefer if they don't like graphs. If you're able to visualize the graph, me personally, I just draw a quick sketch of the graph and I'll say, oh, okay, they're asking for the maximum. So that must mean I'm going for the smaller x value, because if you're thinking about the x axes, this one would be the smaller x value, that would be the larger x value. Hopefully that makes sense, but you can do it either which way, okay? They don't really get too much into it, that is more A level, but I just wanted to kind of quickly brief you over this. Personally, I would say stick to this, it's much easier, you don't have to worry too much about working out, and you only need to know the basics. You don't need to worry about doing small steps right now, okay? So, going through some of these questions, you will notice that these questions don't get as complex as what I was talking about. So, going through these questions, it does say classify them by considering the shape of the curve. So, it's find the turning points. It's not too complicated. So if I just do say 1 is x squared take away 2x plus 3. Okay, so that's my y equals. Why did I not put y equals? Okay, so to find the turning point, I know the gradient's going to be 0. So dy dx is 2x take away 2. This just becomes 0. Okay, so dy over dx, which is my gradient, will become 0. So that means I just need to solve this. This would be 2x equals 2, x equals 1. I know that I've got x, y. So if x equals 1, what's my y? So then you actually need to work out what your y is. So get this x value and pop it back into this equation. So I'll say y is 1 squared, take away 2 times 1 plus 3. Okay, so that's 1 take away 2 plus 3. So that's negative 1 plus 3, which is 2. So this is my turning point. It doesn't actually ask for the type of turning point, but if it did, I would say, look, that's my highest power is x squared, so it's a quadratic. So it's just going to be a parabola, and because it is a positive value, that would be this type of shape. So if they did actually ask what type of turning point, it's not that hard to surmise that it is a minimum, okay? So you don't have to worry about putting x equals 1.1 and x equals 0.9. All you have to do is just say, that's the shape, it's a minimum, okay? So the next one I want to look at is, let's look at 4. Should I look at 4? 4 looks quite promising. So we've got y equals 12, take away 8x, take away x squared. Okay, so still asking about the turning point. So dy dx, that becomes 0. This is 8, and this is negative 2x. Okay, so dy dx equals 0, negative 8, take away 2x, so that's 2x equals negative 8, so x is equal to negative 4. So exactly the same, so I've got my x, y point, so I've got my x is negative 4, so I just need to pop that negative 4 back into this equation. So y equals 12, take away 8 times negative 4, take away negative 4 squared. So this would be 12 plus 32, take away 16. So 28, I think. So that would be my turning point. And if they did actually ask for what type of turning point, you look for the highest power. The highest power here is my x squared, and that's a negative coefficient. So I know it's going to be this type of graph. So that would be a maximum. Okay, hopefully that shouldn't be too hard to look at. And then you just need to apply that same kind of logic to other kind of questions. So if I was, say, looking at question number 9, it says the number of people entering a concert hall 2 minutes after the doors are opened is modeled by the equation. So instead of y, they're putting n. Instead of x, they're putting t. So actually, let's just go through it rather than me just talking about it. Okay, so we've got 9. N equals 50t squared, take away 300t plus 500. Okay, so instead of y, they're saying n. Instead of x, they're saying t squared. So they're asking for dn over dt. So that's the same as asking for dy over dx, you will notice. Okay, so I've got 50t squared, so the 2 comes down, that's 100t. And then I've got take away 300, and this just becomes 0, so that's fine. And then it says calculate when the minimum flow of people are. So when they're saying minimum, they're actually cluing you in on what type of graph it is. So this is a positive power, so I know that's going to be the parabola. So what would I expect here? This would be my minimum. So when they're saying the minimum, all I need to do is find out when the gradient is 0. So this is part A. So part B would be 0 equals 100t take away 300. So 100t equals 300. So t must equal 3. So when it says calculate when the minimum flow, that's the key. It does actually say when. So I can't just put t equals 3 because in real life context, that wouldn't make any sense. No one would ask me, when is it t? They would say, what time? So now I need to find out the time. So it does actually say that the doors open at 8 p.m. and they're saying t is minutes. So these are actually minutes. So if the doors open at 8 p.m. and I know that it's going to be 3 minutes, that would be plus 3 minutes, which means it would be 8:03 p.m. and that would be the time. Okay, hopefully that makes sense. But that would probably be the most complex you would kind of get perhaps. So they'd give you the clue in the question. They wouldn't ask you to calculate a little before, a little after. They do usually spell it out for you, especially when it comes to differentiation questions and at IGCSE. They do give you all the hints in the question. So you've got this exercise, which is exercise 4. Obviously, you've got exercise 4 star as well, which actually carries on to the next page. So otherwise, you can finish off the questions on this exercise, or you can try 4 star. It's entirely up to you. But once you've done them, can you please obviously just take a photo, upload, submit. I'll check them out. Okay, take care, guys. Oh, yeah, any questions, obviously let me know. I am available throughout the day most of the time. Even if I'm like with other people, I will respond to emails and any questions you may have. But do take care. Make sure you get your vitamin D. It is important. And stay safe.